Today we're going to dive into the world of AV drawings from the perspective of a complete beginner. Maybe you're just getting into the AV industry, or maybe you're a project manager, an end client, or another trade working with AV and need to understand the drawings and documents. Either way, by the end of this video, we'll have you navigating confidently like a pro. So, my name is Rupert Brown. I'm an AV consultant. I've been involved in AV design for over 15 years. I am an independent audiovisual consultant, as well as the founder of the AV 500, which is a community specifically for AV designers and consultants. Now, when you first pick up a big drawing set, it can be quite daunting. It all can look like quite technical and a lot going on, but I think really once you know which drawing to look at to find the information you're after, it's actually pretty straightforward. So now standards are not standard, so the amount of documentation and how it looks will vary from company to company, and it will depend on the complexity of the project. So this guide will probably vary from what you will be presented with, but it should give you a pretty solid understanding of all the different kinds of drawings and what their purpose is. So I'm going to start off with the most fundamental stuff and then work through to the less critical things as we go through this guide. So first off, the napkin sketch. So if you find somebody working from one of these on site, I want you to keep calm, take a deep breath, turn 180 degrees and run away in the opposite direction and find an AV professional immediately. That is a joke. I promise the rest of this video, I couldn't help myself, the rest of this video will be a lot more educational. So the foundational drawing really is the floor plan. You can think of this like a map of the space, and it's a great way to orientate yourself. It shows where everything goes, including the power and data requirements. So now let's take a closer look at a small room. Now, if you're lucky, you might get a legend on the side of the drawing showing you what all the icons mean. Here, I'll get myself out of the way here. More often, you'll find you've got a legend page at the front, so one page that has all of the icons which are used on that project. And sometimes you've just got to figure it out based on what the icon looks like. So if we have a look at the drawing here, you can see here's a door, so at the front. So with the floor plan, we're looking top down. This is like a bird's eye view. I can see I've got a little blue rectangle here, and if I consult my legend, I can see that that is a room booking panel. And then there's a triangle, a blue triangle with a 1. So I come to my legend, blue triangles, data points, Cat6 data points. And the 1 inside of the triangle dictates how many of those are required. So I can see that there is 1 data point required here at the touch panel location. So, quick test for you if you're following along so far. Can you see where the LCD display in this room goes? Over here, right? Bam, you're natural. So this really isn't that hard. We're just looking at the icons and figuring out where they're placed inside of the room. It's worth noting that these are usually icons, not scale drawings of the equipment. So don't assume that they will match the actual size of the real life object. So on this plan here, I can see everything that's going on the floor, on the walls. There's nothing on the floor in this case, but if there was something on the floor, it would be shown here. But what about the stuff on the ceiling? How do I know what's going on up there? Well, it's common to see these items also placed on the floor plan. So in this case, I can see two speakers here placed above this meeting room table. And it can be quite useful to have the ceiling stuff on the floor plan because it gives us context around the furniture to understand where the users will be in the room, which is helpful when looking at speaker and microphone placements. However, in more detailed and coordinated projects, we use an RCP. So RCP stands for Reflected Ceiling Plan, and you can think of this as like a floor plan or a map of the ceiling. The term reflected in Reflected Ceiling Plan refers to the idea that the ceiling is drawn as if you're looking at the ceiling's reflection placed on a mirror placed below it. So it's not exactly what you'd see if you were looking straight up, because that would be kind of inverted to the floor plan, because you'd look down for a floor plan and look up for a ceiling plan. And so if we did it that way, they kind of wouldn't line up with each other, if that makes sense. But rather, it's like seeing the ceiling's layout as if it's reflected back to you. Hopefully that kind of makes sense. So in the RCP here, you can see I've got the actual the ceiling tile layout, and you would, in a more coordinated project, you'd hope to see the HVAC systems and the sprinklers and all of that sort of thing, so we can coordinate that all together. Okay, so coming back to our floor plan, you can see we've got a whole bunch of plates and data points and stuff that's happening at the display location. Now, in reality, this is all on the wall, so would be kind of stacked on top of each other when we're looking down from the top in this view. But if we put all of the icons on top of each other, the drawing would be unreadable. So the floor plan kind of shows us what is on the wall and what's in the room. But if we want to see exactly where everything is positioned, we need to look at the elevations. So elevations are like looking at the wall as if you were standing in front of it. You should be able to calculate the exact measurements of where to install all of the equipment and the supporting services like the wall reinforcement, the power and data from the elevations. Now, display elevations are the most common kind of elevation in an AV drawing set, but we have another kind of elevation that also serves a very different and important purpose, which is the rack elevation. Now, a rack elevation is really showing us where the hardware should be installed inside of the equipment rack. And ideally, it's also going to show us the power draw of the equipment and also the heat output of the equipment. So when they're designing, if it's going inside of a comms room, they can design it correctly as far as ensuring that there's enough power supply and there's enough cooling for all of the hardware that's going inside of it. Elevations also have a lesser used cousin, which we call a section. Now, a section is like the elevation, but instead of looking from the front, we're slicing through a building or object to reveal what it looks like from the side. It's as if you're peeking inside to understand how things are stacked. And the sections are commonly used for recessed displays and things like that. So you're looking at the depth of the bracket, the depth of the display, and then how that relates to the overall build-up of the wall. Next up, we have details. So details are kind of like, I guess what they sound like, they're details. This is kind of a catch-all for any specific kind of detail that needs to be communicated. Often you'll see things like seismic mounting instructions and things like that captured under details. Okay, are you still with me? You're doing great, you're doing well. I know this is quite a lot. I'm trying to make this as condensed as possible, but hopefully this is all making sense so far. And I wanted to just break up the white sheets for a moment, but we've only got one more type of drawing to cover when talking about the physical environment, and that is renders. So 3D renders help us communicate the intended final outcome. These are often produced for the client and the stakeholders to understand the proposed design, but in my mind really they're just as useful for the installers, the collaborating trades and consultants, so everybody can understand what the final vision looks like. So now we know where everything goes and what it should look like, but how does this stuff all connect? How does it all go together? So this is where schematics or wiring diagrams come in. Now, these terms actually normally get used interchangeably, but they're technically not the same thing. So we normally produce schematics to show all of the connections in the system, so how everything wires up. Whereas a wiring diagram, if you really want to get specific, a wiring diagram should actually show the type of cable and what the pinout on the connectors looks like and that sort of thing. That kind of drawing is less common in general AV projects, and sometimes on the broadcast side of things you'll see a bit more of that sort of thing. And the wiring diagram might have more specifics around the actual cable routing, how everything gets everywhere. If that's all sounding like a bit much, I wouldn't worry about it too much unless you're working for the AV integrator. You probably don't really need to know about these kind of drawings. They're more for the people that are deploying the systems. Okay, so that really covers all of the main drawings that you're going to come across inside of an AV drawing set. So are we done yet? I'm afraid not. We haven't even begun to talk about documents. So alongside of the drawings, you usually have other documents that go as part of the AV set that you may need to read in conjunction to really understand what's going on. So first of all, and probably most important, is a scope of works or a functionality brief, which is a written document that explains what happens inside of every room and how it should function. The scope of works, or this functional brief, it has several different names. will often be used by the programmer. So if there's a control system involved, he's going to be looking at the scope of works to understand what it is he needs to make this room do. The other thing that you may have as an appendix or as part of that scope of works is a functionality matrix, which if you imagine a spreadsheet and you've got all of the rooms down the column, and then along the rows you have all of the different kinds of possible functionality that you might have inside of the room, and then basically that is a matrix, and so you put a little tick in the box for whatever functionality is required for each space. A project plan or project schedule is essentially like the timeline for the project, usually handled by the project managers, often displayed in a Gantt chart type manner of the whole process from the beginning of construction, the design process, construction, right through to commissioning and completing. GUI, graphic user interface design guide, should be informed by the client's style guide, so all the branding looks right. It's essentially a document, and this, again, some of these things are usually included in the scope of works, or they may be a separate document, but the GUI document basically says this is what the touch panels should look like, this is the look and feel and how everything should operate. The network requirements guide is for the IT department so that they can ensure that the network is ready for all of the AV equipment and set up correctly. Building integration specification talks about how the AV control system connects with the rest of the building's infrastructure. So connecting to the BMS, connecting to the lighting system, to the HVAC system, maybe integrating with security, with the lifts, whatever other systems inside the building is going to integrate with. We need to communicate that with the suppliers of all those other systems and make sure everything can talk together nicely. Bill of materials, or commonly called a BOM, essentially is a list of all the equipment that's going to go in, so that's really important with regards to your procurement process and actually purchasing all the equipment that goes into the system. Cable schedules, often the integrator or the AV integrator won't run all of the cabling themselves. There'll be someone, maybe an electrician or a data cabling company, that's running a lot of the cabling infrastructure that the AV system will use. Cable schedules like a big spreadsheet, basically saying we need this kind of cable to go from that point to that point, and tick it off as you go to ensure that if a third party is running all of the cabling, or if it's being done in-house, that basically every cable gets captured and run. Finally, commissioning, UAT, which is user acceptance testing, is a sheet that happens once the system has been deployed and commissioned to go through and basically tick off to say every room is functioning correctly and doing what it's supposed to do. The UAT sheets are usually informed by the scope of works or that functionality matrix that the client has agreed on. This is what we need to be delivering. And that's a snapshot. There's a lot of variations, and some of these things will have different names, but that's a lot of the documents that you'll usually come across in a sort of a large commercial AV project. So, quick summary. Floor plans give us a map of where all the stuff goes. The RCP is a map of the ceiling, where all the ceiling stuff goes. Elevations will give us all of the measurements of exactly where things are installed. The rack elevations show us where the equipment goes in the rack, what the power usage is and the heat output. A section is slicing something in half so we can see inside of it. The details give us specific details or instructions for particular things that are very specific to the project that the designer wants to share. Renders gives us a view of what the final outcome should look like, and the schematics basically show us how everything connects together. If you can get your head around all of that, then you should be able to, if you're looking at the right drawing for what you're trying to find, you should be able to figure it out from what you get. Okay, a few final quick thoughts. If it's not on the drawings, ask. Particularly if you're a technician, your client, or anybody. The drawings, in theory, should have everything that you need. Reality is they don't always. Don't make assumptions. Just ask the design department. Ask the people that did the drawings. There should be contact details on the drawings themselves. It's better to ask than to assume. Same thing goes for site dimensions. So even on projects, these multi-million-dollar projects where we do a very high level of coordination and BIM modeling and all the rest of it, sometimes the wall isn't built to the exact same dimension that is on the plans. So you do get some variations in reality. So you might have a measurement on a plan that should be the middle of the wall, but it's actually not quite the middle of the wall because something hasn't been built correctly. So I guess that's more for the technicians, but again, don't assume that those site measurements are going to be 100%. Again, terms and processes vary by company and region. I'm trying to give an overview of an unregulated thing that will hopefully be helpful to anybody anywhere in the world. So I'm sure some people will disagree with some of what I said, but I think this should give you a pretty good overview. If anything isn't clear, feel free to leave a comment below and I'll do my best to help you and answer it. That's it. You made it. Well done. Hopefully that was helpful. My name is Rupert Brown. I am an independent contractor, so if you need an AV consultant, feel free to contact me on av500group@gmail.com. I also run the AV500, so if you are a AV consultant or AV designer, we have a community specifically just for us, and we cover everything new technology. We do independent drawing, we do drawing reviews. Anything to do with AV design is all happening inside of the AV500, so school.com/AV500. Please check it out. Thank you very much. And again, if you have any other questions, please leave it in the comments below. Thanks, guys.